Okay, let's take a look at how we might go ahead and factor this trinomial here. We are basically taking the number negative 16 and looking for two numbers that multiply to negative 16 but also add to the middle term of positive 6. Now we're doing this because there's a 1 in front of the square term. That's why we can do this. And I think you can see that 8 and negative 2 multiply to negative 16 and add to positive 6. So we can factor this trinomial up here like this as a c plus 8, and then another trinomial is c minus 2. And that's how you factor that trinomial. Okay, well, we can try it again here with this trinomial. Again, we still have a 1 in front of this square term, and we're going to still operate kind of under the same way, but what we're going to do is we're going to take minus 16, and this time we're going to look for two numbers that multiply to minus 16 but add to negative 6. Just like we saw before in the last one, we know that's going to be 8 and 2, but this time the 8 is going to get the negative, and the 2 is going to get the positive, because again, that's negative 16, but now we multiply to negative 6. So once we have that, we can go ahead and factor this thing like this. We're going to put one set of parentheses, then we'll put our t. This is a t. I know it looks a little weird, that's how I make my t's. And then we're going to do the minus 8 thing, but this time we'll put minus 8, and then we'll actually include the g right there. And then we'll make another set of parentheses and do a t. And this is where we're going to put our plus 2, just like we did the last time, except that, again, we're going to include the g on the end. And there's the factorization of that trinomial. We're going to work with this one, I think. First thing we're going to do is take the number 28, and again try to find two numbers here that are going to multiply to 28 and add to 17. If we look at that, though, if we look at all the ways to get to 28, obviously we have 28 and 1, and well, that's not going to add to 17. Then there is, let's see, what is that, 4 times 7. That's also 28, but that's not going to get to 17. 2 times 14, when added together, makes 16, not 17. So in this case, since there are no numbers that are going to match that, we're going to say this trinomial is prime. Alright, let's take a look at factoring this one here. It does not have a 1 in front of the square term. So one way to do it would be to, well, let's just try some things. First of all, if we just look at the binomial, the two binomials, we notice this is a 7 here. Now the only way to get to 7 that you can think about is what? 7 and 1. So we know this has to be a 7c and then a 1c, or just c. And then over here we have a 4. Now there's a couple ways to get to 4. There's 2 times 2, and there's 4 times 1. But notice I'm going to get to 27. 27 is pretty close to 28, which is 4 times 7. So if I put the 4 right here, notice that when I multiply the 7 times the 4, I get to 28. And if I put the 1 right here, I get to 1. And 28 and a 1 will get me to 27, as long as this one is negative and this one is positive. So that's one way to do it. That's a positive 1 right there. Okay, that's one way to do it. Okay, another way to look at this is to multiply the 7 times the minus 4 to get the negative 28. And then we'll go ahead and figure out two numbers that multiply to negative 28 and add to negative 27, so that would be negative 28 times 1. And then we can change this middle term like this, 7c squared, it's a square, 7c squared, let me redo that. 7c squared, and then minus 28c plus c minus 4. And then we can do this and factor by grouping by pulling out a 7c there, and we'll get c minus 4. And then we have a plus, and I'll just get parentheses around that, c minus 4. And then there's an invisible 1 in front of here, so I can pull those out and say 7c plus 1 times c minus 4. And you can see that's exactly what we got up there. Okay, what we have here is a difference of 2 cubes. I'll remind you here that 3 raised to the third power is equal to 27. So what we have here is b cubed minus 3 cubed. And this will be your x and this will be your y in the formula over here, so we'll just plug them in. So b minus 3, so we'll have b minus 3, and that's according to the formula right there. Put that in parentheses. Right there, b minus 3. And then b squared. And then b times minus 3 would minus 3b. And again, according to the formula right there. And then 3 squared is 9. So we just add those in, and we are done. All right, one more time. Let's go ahead and factor this sum of cubes, because we will take a quick note here that 1 does equal to 1 cubed. Let's see what we got here. We got, just for a quick note, 1 does equal to 1 to the third power. So we can write this as b cubed plus 1 cubed, because 1 cubed is 1. And then we'll be using the top one up here, so it'll be b plus 1. That's for the first part here, right under here. I'll underline it. And then for the second part, we'll have b squared, and then 1 times b, but it'll be negative, so minus 1 times b, which is just b, and then plus b squared, or plus 1 squared, excuse me, which is still 1. So yeah, 1 is your y component 1. Yep, so there we go. We're done. Alright, I've pulled up another one here. 2x to the 7 minus 12x to the 6 plus 8x to the 5th. Notice they're all divisible by 2, and they all have at least an x to the 5th, so I can pull those two out of them and get this as a result. But I can still factor this trinomial, so we still keep our 2x to the 5th on the side here, but then just factor this trinomial. And I think what we'll see here is this will be x minus 2 and then x minus 4. Now notice that minus 2 times minus 4 is positive 8, and minus 2 minus 4 more is negative 6. And if you reverse that order, that's fine. Okay, for this one, we're going to use an interesting technique. I'm going to go ahead and say, let's make u just a random variable, and we'll make that equal to p plus 7q, because that's what's inside both of those binomials. So when we're done, we're really going to be looking at u squared minus 8 times u plus 16. Okay, let me go ahead and let's talk about why that's good. First of all, this will factor easily into u. Let's see, we want to get to negative 8, so we're probably going to do, what do you think, negative 4 and negative 4? Because, once again, minus 4 times minus 4 is positive 16, and minus 4 is negative 8. But remember, we changed u into that p plus 7q, so what we really want to do is change each of these u's back into p plus 7q. So for the first one, we'll have not u, but p plus 7q minus 4. And notice that will be the exact same thing for this one. So we'll have another one here, but instead I can just write a 2 here as a square. And we will have it. Okay, this will be the last one for homework 3. I want to go through this whole thing. Notice I can factor by grouping right off the bat here, since we can do the first group will be x plus 7 to x to the 5th, sorry, plus 7x to the 4th in the first group. And in the second group, we'll have the minus x and the minus 7. And we'll do this. We'll pull out an x to the 5th here, and then we'll have x plus 7 inside the parentheses. And here we'll pull out a minus 1, and we'll have x plus 7 in the parentheses. Sorry, that's an x to the 4th right there. That's what I meant to say. Let me fix that real fast. Okay, so I fix that to x to the 4th. Then what I can do is factor by grouping to have x to the 4th minus 1 times x plus 7. Now you think we might be done, but we have some more work to do with this piece right here. Let's take a look at x to the 4th minus 1, this piece right here, so we can write that as x squared to the second power minus 1, because x squared squared is x to the 4th. And this becomes a difference of square, so we can factor that out to x squared plus 1, and then x squared minus 1. And we can also do this last x squared minus 1 as, well, we should get x plus 1, x minus 1. So this one becomes x plus 1, x minus 1. Now putting all this together, we still have our x plus 7 there, so this will be the answer. X plus 7 times x squared plus 1 times x plus 1, x minus 1. Okay, notice that we use this one here, and then we refactored that one into these two, and then we refactored that one into these two. So there's 3 components here. Now we don't have to refactor x squared plus 1 because it's the sum of squares, not the difference of squares. Okay, that finishes up chapter homework 3. Hopefully that works out to help you.